Well, hello, everybody. Welcome to the last session, or one of the two last sessions of our first day of Smart Building Exchange Conference 2023. The title of this session is Being Smart About Variable Occupancy. My name is Tom Marseille with Sazan Group. I'm going to be your moderator today, and I'll let these people introduce themselves when we get going here, when they each get their first chance to speak. But I'm just going to let you guys know if you're wondering what we're going to be talking about. I think the impetus from it, though I would say it's the impetus for why we're talking about it, but that's not the only reason, because I think we've been seeing changes in workplace anyway happening now with being disconnected or connected, being remote and being able to work anywhere. But I guess coming through the pandemic and the changes we're all seeing in workplace in terms of whether you're in the office, out of the office, somewhere in between, is driving a new conversation as we start to talk about smart buildings and how to make better performance in buildings and better performance with people and provide them the conveniences and security and those things that are important. So we have a very kind of wide-ranging conversation we can have on this topic, but we've got some very interesting folks to help us along the way. And so I'm going to start asking each one of them to give a little bit of a structured presentation, and we're going to go through each of those. And they'll be introducing themselves a little bit, and I'll be introducing them as well at the same time. For questions and answers, you can put them in the Q&A portion of the Zoom call at any time. They'll be monitored, and we will either bring them up at the time when they come in if they seem highly relevant to the situation, or we may, in some cases, I may choose to save them towards maybe the end of a particular question or presentation, as it may well be easily addressed or better addressed at that point in time. So Q&A, use that when you have questions. And let's see, anything else to say before we get started? I guess that's it. So I'm going to have Cindy Zhu start us off. She is the Director of Grid Services, which is an interesting title, with Prescriptive Data. Cindy, take it away.
Awesome. Thank you, Tom. And just want to make sure that everyone can see my screen right here. All good? All right, great. So thanks everyone for joining virtually with us. We're going to talk a lot about occupancy data and various use cases for it. As Tom said, my name is Cindy Zhu. I work for a company called Prescriptive Data. We are a software company headquartered in New York City. We cater to commercial and corporate real estate, and we've got clients all over the country as well as in Canada. Our software is called Nantum OS. And today I'm going to talk about how we use occupancy to optimize HVAC and save energy. So Nantum OS is all about bringing what people want to know into one place. So we call this a centralized building data lake. We are integrating typically siloed sets of building data, such as controls, BAS data, HVAC data, security system data, as well as energy data and occupancy data. Our clients sometimes ask for additional integrations, such as IoT devices, really whatever they want to bring together, we are able to pull that into our centralized data system for Nantum. What is the result of getting all of this data together? Benchmarking, as well as data points to monitor a foundational baseline situation, as well as unique data such as knowledge about the health of a space, like air quality. And then our unique piece of data that sets us apart is having that real-time occupancy data. So occupancy can be measured in a number of ways, and I think this group will talk about the various ways to pull it. But for us, occupancy will feed into real-time data coming from the BMS system, which is where we can really help command and control equipment to save energy. Occupancy can also impact how an individual feels about being in a space. Again, wellness benefits, climate benefits, we'll dig into that later. So for us, we are a data science first company. So what that means is after we integrate all of that siloed building system data together, we start running AI and ML models, algorithms to understand the building use patterns, its performance capabilities, pull in weather system data, and then really start running that building's variable energy use to really reduce waste. So what you're looking at here is a representation of what we like to say before NANTM and after NANTM. So that yellow line curve is our typical old electric demand curve that we see in buildings. Startup is very early in the morning, especially on a Monday, especially during shoulder seasons. That red line is real-time occupancy. So what NANTM is able to do once we get occupancy data integrated is it's going to start trending those occupant traffic patterns, right? So what time are people coming in on a Monday, Tuesday, Wednesday, Thursday versus a Friday? Now during pandemic, it's more like, a Monday, Fridays look very different than Tuesday, Wednesday, Thursday. It's going to start trending when people leave for lunchtime, right? Exit the building, come back in the building, and it's going to start trending when people actually start leaving at the end of the day in the early afternoon. What we're then able to do with NANTM is start sending commands to the HVAC to actually start up at the most efficient time to deliver comfortable air temperatures to when people actually show up. We can start doing some ramping of air handlers during that lunchtime hour, again, when people are exiting to go out to lunch, as well as at the end of the day when people are going home rather than waiting to shut off all at the end of the day. So I'm going to go straight into some interesting use cases that we've seen through the years. This one is a oldie, but still a goodie. If you guys remember, there was a national solar eclipse in 2017 that a lot of the country was able to see, including our clients in New York City. So what we saw was occupancy during that 2:30, around 2:30, everyone in their office buildings went outside to go look at the sun. And NANTM recognized that. And you can see electricity actually dipped at that same time because it started ramping down those fans to accommodate all of those people that actually left the building, reducing the heat load gradually. And then they came back in after the eclipse, and you can see electric demand comes back up to deliver that comfort air back into the building. With COVID, we saw a lot of interesting things. So in New York, the governor made a stay-at-home mandate. I believe that happened on March 15th. So that top chart on the right, the big red spikes, that's occupancy trends during the days leading up to that stay-at-home mandate. And then you see that number falls down a lot. And because we had occupancy being tracked at a good number of buildings within Manhattan, we were actually able to share that data, see how many people were actually following that mandate versus how many people were kind of required workers that had to still come into the office. Likewise, in 2021, we started people starting to come back into the office, right? So we were able to use our occupancy data to really keep track of, what are the trends? Are people actually returning back to the office in in April through August 2021 compared to the previous years? And, I'm sure we're all aware that, its occupancy trends have really changed probably permanently. And, in New York, we're still kind of hovering between 50 and 60% of pre-pandemic occupancy numbers. As far as energy goes, having occupancy integrated to command HVAC has been quite interesting throughout these post and pre-pandemic years. So this is a case study of an office building in Washington, D.C. that has floor level air handlers. So air handling units for each floor. Because of that setup, we were able to install occupancy sensors for each floor. That way, those energy conservation measures that I shared earlier can be done down at that floor zone level. So really optimizing for occupants on each floor, so each tenant. So before the pandemic started, we were able to set up some rules around how to start up that floor based on what number of people are there. So this building has a standard lease agreement of 8 a.m. So they need to, they are legally required to deliver comfort temperatures to their tenant floors by 8 a.m. What we were able to help them do is track occupancy, especially if people are coming in earlier than that 8 a.m. hour. Specifically, we set it up so that if the occupancy counters found at least three people coming in early before 8 a.m., then their floor can be triggered to start up and deliver cooling. If there are not three people on that floor, then Nansen will delay that startup to reach comfort by 8 a.m., their standard time. Here you can just see each floor, whether it was an occupancy triggered startup, right, that early startup, or was it that standard lease agreement startup, and exactly what time that was happening. During COVID, right, occupancy dropped, especially in DC. A lot of office spaces were pretty much empty. So we worked with the client to really figure out, how can we use Nansen to really push energy savings, given that we have these zone level occupancy sensors set up and connected to Nansen. So with this client, again, we were able to delay that startup time past 8 a.m. If there was very, very low occupancy on the floor, which for many months there was. Our lunch ramp down periods were longer, right? People were leaving for longer periods of time. If they were coming into the office, they were leaving the office earlier than expected. And then we also started playing around with a occupancy triggered early shutdown. So this building typically has a shutdown of 6 p.m. As part of their lease agreements. We actually started setting up rules where if no one was on the floor past 2 p.m., and it remained empty for at least 30 minutes, then that floor can just go straight into shutdown rather than wait until 6 p.m. Now, as we've exited that immediate pandemic period, we've started pushing that back, right? More people are coming in the office. So rather than early shutdown at 2, let's push it back to 3. And now we've actually got it set up to 5 p.m. Again, still an hour earlier than their standard lease agreement, but really delivering a good number of savings at this building than typical. So here we've got a number of reports. The case study that I just showed with the zone level commands is the tower companies one on the far right, evaluated by Lawrence Berkeley National Lab. So feel free to go to our website and learn a little bit more. And then I think I'll pause here and allow my fellow panelists to share their occupancy use cases.
Awesome. Thank you, Cindy. This is, for an engineer like myself, just seeing all that data gets me going and saying, oh man, there's so much stuff you could do with this. And so the magical question that showed up in the Q&A, which I think we don't have to answer right now, but is how do you find out how many occupants you have in the building? But we can save that for the group discussion. So let's move on to panelist number 2, Craig Engelbrecht, who is the Vice President of Long Building Technologies, is going to take us on a fun little short tour here, a day in the life or whatever you want to call it. Craig, take it away.
Well, good afternoon, everyone. This is Craig Engelbrecht with Long Building Technologies. And occupancy has been traditionally tracked by OCC sensors. And we know as technology has continued to evolve that's changing. And so I wanted to walk through how we are seeing technologies. We're a building automation and lighting and security systems integrator. So we're seeing a lot of IoT devices starting to create opportunity to be able to see occupancy. So what I'm going to do is just walk you through. So I just walked outside and flip around my camera. So as a visitor coming, I can actually, with my visitor management, issue an invite, and someone can pre-register, and then it actually gives them mobile credentials. So when they walk up to the door and they wave their hand, it unlocks the door. Similar to our occupants, all of our occupants use everything is on the mobile. So we know when they're in the office, we know when they've use their credentials. And so we have our access control that's giving us one point of reference. Number two is we have cameras. And so cameras now have the ability, analytics on top of the camera, to be able to start counting. And so you can show a line on the camera view and count in and out. So we have a camera at each door location. You could have it in the elevator lobbies, and you can start to count individuals coming in and out. We also, we just refreshed our office. And so we also wanted to implement a lot of this of what we sell, what we do, what we implement with our customers is, eat our own dog food. And so we just implemented all of this in our office to show how some of this will work. So when I walk in as an occupant, Craig Engelbrecht, it then says, oh, Craig is here, it's recording, it does a count. It also, we have a environmental sensor here in the entry. That environmental sensor is giving us particulate matter, VOCs, vape sensor, but it's also doing people counting in multiple ways. So it's giving us a people counter. We have an ox sensor and a light level sensor. But when I come in, it says, hey, Craig's here. And then it goes and sets my thermostat in my room to my desired temperature. So as I walk in here, my thermostat is then set to my 69 degrees. And then it also allows my blind control and my lighting control to be automated at that point in time. Now, right now, it's at light level sense. And so I'm able to run at the ability to control my lighting with my light sensor to be able to manage the shades and the light levels. And so I'm also connected via Bluetooth. So my mobile phone is connected to these devices when I walk in. And so now it also gives me the connection with a Bluetooth sensor to know how many sensors are being connected to. What's interesting too is just a little side note, we were able to remove every single light switch in our entire office. And now this is the light switch to turn on and off the lights, set your dimming and set your percentage or set it in specific modes. It also allows us to control thermostat and shade control. And we can also say, Alexa, close Craig's office, and have our blinds have automated set temperatures on thermostats. And so the last component of this that I just want to share is that sensors are becoming ubiquitous, right? They're everywhere. This is a small sensor that is made by Disruptive Technologies, and it's a proximity sensor. And you can have other ox sensors that are then connected to different systems. And everyone has technology. There's IoT devices coming out. There's more and more technology available in each of these systems. The challenge we have is, how do we bring it together? How do we start to leverage like what we just saw from a software perspective? And so there's technologies around here like this controller that instead of talking backnet to backnet, we're talking APIs to APIs. We're talking webhooks to APIs, and we're talking cloud to cloud. And so our traditional building integration has been, oh, does it talk backnet? Does it talk Modbus? Does it talk a protocol? How do I get data from this, security system into a control system? And it's been a very difficult and very challenging ability to do that. Today, technologies can be able to talk to each other much better than they've ever have been. And so the ability to have all of these disparate technologies come together through software that we just saw, or into a control system head end, front end, or into other systems to be able to help us control and optimize the building to be able to drive demand control ventilation, to be able to drive air quality. It's never been easier than it is now. And it's now at an IT level, not at a traditional control system level. That's the 5-minute version of just trying to give you a real life, real world situation that we're doing and that we help our customers through.
Thank you, Craig. So some years ago, I remember we used to do these cartooning of these scenarios, a day in the life, kind of thinking about how it would be if you're a visitor or an employee coming to these spaces. And so we had all these cartoons and we present these presentations. And I feel like, you know, you're the living cartoon, you know, cartoon come to life a little bit. And it's kind of what we're talking about. So that's why I told everybody, I asked Greg specifically, I wanted him to do this because I thought this would be kind of fun. So there are a couple of questions that came up as well, 3 actually, I think. And you know, I don't know if this is a plan to be yours, Craig, but they said, what's the name of the controller, the model of the branch? And so I thought it might be one of yours, but you want to divulge that?
Sure. This particular one is a Distech controller, but there's the key is it has the ability to store Dockers and containers. And so if you're not an IT person, you're like, what in the world's a Docker and a container? Well, that's the type of conversations we're going to be having in the building world moving forward, because that's a traditional IT conversation. These are very standard in the IT world. And the ability to host a container or Docker that has integration between a cloud technology and a webhook on a camera is now the reality of how we do integration, not how we've traditionally done it.
Yeah, I'm kind of glad that the 30 years ago when BACnet was the thing. We're not going that route as much anymore, at least not the way you guys are talking about it. So
yes.
We've moved on that. So another quick question someone had is, do you have motion sensors too in your office so that if you're not there, the lights go off and all that stuff? Yeah. I assume.
We have scheduled that aux sensor. It does have motion. You know, it's the aux sensor in the ceiling. It's about that big around. It's just a little motion sensor, aux sensor, and a light level sensor.
Okay. We got one other question, but I think I'm going to save that. I actually have a couple more questions. Let me see if we save those or use them now. Let's see. I think we're gonna save this other question. It's about applications of Internet of Things devices in larger spaces and some of that. We'll save that for conversation a little bit further because I want to get to the other 2 presenters, and we'll come back to Q&A in a bit. So next up, thank you, Jay, by the way. Next up, we've got, Craig. We have Jay Martin of Overcast Innovations. He's the Director of Engineering, and we'll let Jay have the helm, so to speak.
Thank you, Tom, and thanks, Craig. I'm gonna be the person trying to follow your tour with a traditional PowerPoint presentation. So get ready for this. So yeah, I'm with Overcast Innovations, Director of Engineering. Been at Overcast for a little over 3 years, and Overcast has been around for 4 years. We are a manufacturer, product designer, and manufacturer of integrated ceiling systems. So we are a wholly funded startup of McKinstry, which is a design, build, mechanical, electrical, plumbing contractor here based in the Pacific Northwest, but McKinstry rather has 25 offices across the country. And so they were very passionate about trying to figure out a way to kind of deliver ceiling systems in one of their projects a number of years ago, I guess it was 5 years ago when this idea was conceived. So you're going to hear me refer to the Overcast Cloud. That is a physical piece of hardware. 2 examples kind of tied together, and the image here on this particular slide in this conference room are an example of that. So an architectural cloud, not the cloud in the virtual sky, if you will, that you'll also hear referred to. So our system is integrating all the things that you see on that image, lighting and technology. So many of the devices, or actually most, if not all the devices Craig mentioned, are integrated into this system. The idea is is to manufacture this, deliver it to the site, and install it in a very kind of quick and efficient manner. Our factory is located in Spokane, Washington. Our design kind of an engineering team is here in Seattle. We're a union manufactured product. And here you're seeing just the kind of one of the cells on the line at the manufacturing facility. What I wanted to kind of focus on for today's conversation is how we have begun to morph and think about how to make our cloud more intelligent. And I owe a lot of gratitude to Craig Engelbrecht, who was just on the call or in the conversation, who has kind of helped us kind of push the boundaries here with our system using many of the technologies you saw in his tour. So let me jump in here. So imagine our cloud. It's in this example, it's a 6 by 6 piece of hardware. It hangs in the ceiling. In this case, it has 2 linear lights on either side, and those linear lights are tied into one light driver housing. You see here with this kind of with this demo that we've put together with Craig's help, we put a controller, that one of those DizTech controllers Craig mentioned, on every cloud, and a Bluetooth multi-sensor on every cloud as well. And that multi-sensor is doing 3 things, right? It's doing daylight, it's testing daylight so it can understand luminosity. It understands motion, so it's occupancy sensing, and it also understands the temperature. And so I think if you think of each one of these clouds having a sensor, so it has an eye into the room and a controller or a brain, and that's really the key to it. And what I'm going to do now is going to just walk through what this might look like actually next slide. So sorry. Let me back up one moment. So the clouds in a given room are tied to a room touchscreen. Again, Craig showed you that in his office, and also can be accessed via a mobile app. And so on the mobile app that we demoed, in our case, we put up 4 clouds in our wine bar at our facility here in Seattle to show folks what about our technology and about our clouds. And so we have what you see on the left side of the screen is an image of the app with 4 clouds named differently, named for different projects that we've developed them for. And you can independently change the settings on those, right? Change light levels, change kind of how those clouds are reacting, or you can do it in a group. And that's what the all clouds is referencing there. Another view, kind of the next image in the middle there, is just what that interface looks like, how you dim lights. In this particular case, you can dim to off. And then we have various scenes that we have set up. You can see one's called Happy Hour. The lights on our wine bar have both direct and indirect elements. So Happy Hour, for example, has more indirect light. It's kind of creating an ambiance. It turns down the direct light. The bright mode is as you can imagine, 100% turning the lights fully up. That's a good one for December in Seattle. Motion sensing, I think it's self-explanatory. It is looking at the room, and it's looking for motion, and it will, again, each one of those clouds will turn on as someone walks beneath them. Light sensing is, again, daylight. So that's really testing and to show that it can respond to daylight. And in the example in our wine bar, one of those clouds is near a window, so it gets a lot of daylight. So that one is dimmed down, all right? It knows that there's more light and because of the window in that particular example. And another scene we had set up was an occupant control scene. Again, that one is allowing occupants to override the system. And if you happen to sit below one of these clouds in an open office, for example, you can create a favorite. And again, that favorite, it recognizes you when you walk in. Again, this is a Bluetooth enabled device. And it's speaking to the cloud you're sitting beneath, and you can then manage the light levels as you see fit, for example, there. Now I wanted to walk through kind of what this might look like in a room. Here I just put together, this is for a project where we were just doing a conceptual layout on, this one happens to be a higher education classroom. And here this is a 1,200 square foot classroom, and you know, 3 groups of 5 clouds in this room. In this example, we've tied them together physically, and so really, again, the platform can house mechanical diffusers and pretty much any sensor, fire alarm, fire sprinkler, all of those devices. But today I'm really specifically talking about lighting and variable occupancy. So here's just a rendering on what that room might look like. Again, it has 15 clouds, and each one of these clouds, again, in this case study, would have a sensor and would have a controller. And again, what does that look like? Again, here, so now, you know, again, imagine 15 sets of eyes looking down, and it then knows, right, what's happening beneath it. And so in this room, there's the window wall, and it would be sensing the luminosity in that area, and those clouds near the window would basically dim down or dim to off. In the unoccupied zones, those would default to a setting that could be, you know, selected by the owner, or, you know, in this case, maybe the teacher in this room. Maybe they want those, you know, unoccupied default to be at 20% of the lighting level, as an example, maybe. And then it knows, you know, that some of the areas in the room are occupied. And here I just took a crack at what that might look like from a, you know, and how much energy is being used in each one of these clouds, given the scene that you see here with the occupancy that you see here. So in this room, right, in the daylit zone, nothing's really on. In the unoccupied area, it might be on at 20%. I mean, again, you know, that setting could be 20, it could be really any number, that any number that's desired. And then in the occupied area, that's really, you know, those clouds are sensing motion and have turned themselves on. So I think it's pretty interesting use of, you know, the platform that we've, you know, derived, and trying to make it more intelligent. I mean, this isn't necessarily, you know, a groundbreaking kind of thing we're doing necessarily. You've probably heard of something called luminaire level lighting control. And so that was created many moons ago. And that is where, you know, there is a motion sensor or a sensor on every light fixture. We're really using that concept and grouping it in a cloud form, and then, you know, enabling, obviously, with technology today and apps, and then this API kind of controller kind of world that we're living in is now enabling us to, right, tie all these IoT devices into it and control them at a more granular level. So that's really all I had to add today, but thank you very much.
Yeah. Jay, just keeping this slide up for a second.
Sure.
A lot of questions came up in my mind as well as within the chat. You know, the idea of sort of preferences of the person below the cloud, how does that play out when you have a classroom scenario where maybe multiple people are at the same location? I'm sure you've been thinking about all that. Just briefly, if you could say how that sort of that capability is used or not used in this case.
Yeah, I think in this case, I mean, I was considering this more of a free form, you know, maybe like this would be a scene that you would set it to, and the instructor would set it to, where, you know, this, you know, students are moving around the room, and it might enter this mode, and then this makes sense. Obviously, if you were a teacher was at a podium, this makes absolutely no sense. You would change the scene to be, you know, maybe driven purely by, you know, maybe it would be 100% lights on, right? Everyone, lights are up, no sleeping in my classroom of scene. So, I mean, this was a very specific example. Again, I think that the power of this is those scenes that we developed and showed on the right side of this, you know, the slide a few slides back. That was very specific to, you know, the use cases as we thought about them. But you know, Craig's team, right, the building integrator, right, they can take and program those scenes in many different ways, really, to the users, right, to whatever the user desires. So hopefully that answers that question.
Yeah, and things like temperature control are integrated in the same way, right?
Yeah, temperature control is a little It's similar but different. I mean, again, back if you remember from Cindy's conversation, it will be dependent on how the HVAC system is zoned and set up. So you're going to be changing the thermostat, right? And it's going to be telling the air handler near you to do its thing, but that might be in a zone that's larger than this classroom. So
or
that's
just one zone for the classroom. Yeah.
Yep.
Right. Yeah, that makes sense. Okay. Thank you, Jay.
Thank you, Tom.
Let's move on. Last and not least, Zixiao Pan, who's the president of Butlr, who's going to talk about a pretty interesting topic on her own here. I'll let you go with this. Take it away.
Can you disable your screen sharing?
Yes.
Perfect.
There we go.
Thank you.
I did it. Thank you.
All right. Okay, let me see. Let me do the play. Tom, let me know if the team can see my screen.
We're good.
Good. Okay. Thank you, Tom, and good afternoon. I'm working at the intersection of smart building IoT devices and enterprise software, and excited to be here and share a little bit with our audience today, Butlr's observation of occupancy sensing technology, the trend, the evolvement, and our own effort in some of the very exciting fields, right? Butlr was founded about 3.5 years ago at Burlingame, California. MIT Media Lab spun out. We provide space occupancy, traffic, human presence, and activity data. We do the data capturing and visualization, including both hardware and software. The secret sauce there is the series of breakthrough technologies born in both MIT and Berkeley. And with that, we offer high accurate detection and anonymous sensing and a much lower cost compared to the other offerings on the market. We're named one of the World Economic Forum's technology pioneers of 2022. The use cases really cut across, asset planning, workplace experiences and strategy, facility management, and we're also expanding into senior living, where the occupancy data provides a whole new level of value. It's very exciting. I first want to talk about, the occupancy data and the strategy evolvement when we think about the journey, right? Over the past 40-something years, the passive IR sensor has been dominating and becoming the only successfully commercialized occupancy sensor to date. I mean, it's binary data, it's not smart. Today, right, we're talking about a myriad of technologies, covered by Craig's earlier conversation. For example, cameras, there's LiDAR, there's radar, microwave, ultra wideband, and there's a thermal sensor like the one that Butlr is using. All these technologies are providing much richer and really more granular information, right? So this opens new areas of applications like the space use patterns and user behavior patterns, which are used today as input to provide, building level and floor level utilization feedback and drive decisions on energy saving, in addition to that, human resources, ambient control for better comfort. Very interesting there. And then the other thing I think is worth noting is more and more use of predictive analysis based on historical occupants data and the aggregation of various kinds of sensor informations, including maybe badging and HRIS data, and correlate those information to provide more meaningful and relevant insights to the end users. The last thing is that the concern about privacy has also grown significantly as the technology becoming more and more pervasive. So where are we going from here, let's say, 5 years from now? We believe that one or more of these occupancy technologies, the new technologies, will develop to the stage of true commissioning scalability. What I mean by that is the unit economy and the TCO for deploying such technology will make perfect sense by then to be considered as a natural line item in the new build or easily budgeted for retrofit. It also means that deployment, the activation, the data collection, the aggregation, everything should be made simple and straightforward. Butlr has made some really great advancement in that front. We also believe that the next generation occupancy sensing technology should be carrying high responsiveness and being able to, based on the high granularity of the data it can get, being able to enable the microclimate, that is the comfort, the health, the safety, sustainability down to not the level of the building and floor, but more in the smaller zones and even down to individual level. So the future we think is very exciting. We developing sensor systems with high human touch points, including employee experiences and senior care experiences. And we think that a great sensor for that should function like nerve cells, meaning that it should continuously and easily fuel the data into the decision-making function, ubiquitous, right? Does the job effortlessly, providing accurate signal, and also very importantly, work in sync with the other senses. So if you think about the security camera and CCTV as eyes of a smart building, the indoor air quality sensors, the CO2 sensors as maybe the nose, right, of the smart building, our sensing system should functioning just like the nerve cells, right, in the background, and it does not compete with the existing system, but work in sync with them. And second of all, as I mentioned, total respect of privacy is going to be a key consideration. So these are the points that we carry from the day one into our product design principles. First of all, the occupancy and traffic data collected are real-time and 95% plus accuracy. Anonymity, right? So the two images on the left side are what our sensor, quote unquote, can see. So you can see that fundamentally it captures the thermal data from the objects, and the raw data is low resolution, highly pixelated. And the secret sauce in our ML and AI-based algorithm is that we can infer precisely, even if the raw data is highly pixelated and low resolution, right? Affordability, and we are a fraction of the cost competing compared with the competing solutions out there on the market, especially when you take into consideration of the hard and soft cost of installations. The majority of our product SKUs are wireless, so the installation does not need a high voltage electrician, which is a huge plus. API first flexibility, I think the previous panelists all talk about the importance of breaking the data silo and being able to aggregate the data in one platform to make sense. And this is our guiding principle from day one, right? Our customers typically call on an API to bring our data either into their own BI tools like a Tableau or Power BI, or enterprise customers will pull the data into their data lake for further analytics. They can also feed our data directly into any third-party platforms that they're using, which allows them to use this data in synergy with the other applications of the data and sources, very flexible and truly breaks the data silo from there. One sensor kind of a SKU and supporting two different modes, traffic mode and presence mode. And what I'm showing on the right-hand side are some interesting examples, right? For example, the top one is our studio application, which enables both scoping and visualization of the data. Customer's floor plan is imported, and you can see the furnitures and fixtures being placed. The coverage of the sensor overlays on top, and the purple dots are the visualization of people at any given time in real time in these areas. In the middle example, very interestingly, this is coming from one big tech company, our customers. It kind of tells the story of the place, the story of the space of the day, whereby the engineers starting their daily Scrum sessions on the left-hand side. And then, as they finish that, they all move to the right-hand side, which are the open seating area and then the cafe. So they kind of tell you what goes on in their workplace in different times of the day. And if you incorporate the data, the historical data with XY coordinates and the timestamps, you can do cool things like heat maps and get very granular data on the use of the floor over time, like what I'm showing on the bottom right. The use cases are really rich, right, across the value chain of workplaces and offices specifically. First bucket being the real estate, asset management, asset planning. The second one being the employee tenant experiences. How do you think about, for example, integrating that into desk booking, the room booking? How do you do the amenity tracking, et cetera? And then, the third bucket is in the building operations and facility management. One of the very relevant topic there is the smart HVAC. Carrier is one of our Series A investors, strategic investors, and they have this, full suite of solutions, smart building solution called Abound. Butlr is embedded today in Abound, which allows HVAC to respond based on the real-time occupancy information. So in short, right, our goal is not to be the best dashboard, the best business intel in any of these niche segments, but really to provide the user the data, accurately and efficiently. We actually partner with the solution providers in each of these major buckets, and these solution providers in return are among our strongest channel partners. So quick examples here, right? Strategizing these decisions for a large technology company with more than 10,000 employees across multiple countries. Our sensor deployed already across 9 locations in EMEA and APAC regions. In this particular case study, across 2 offices in that region, the client actually used the occupancy data to enhance their offices, you'll be surprised, right? Navigation and wayfinding design. And they use that data to optimize resource utilization. They also set up dynamic room booking systems and made decisions, informed decisions based on the occupancy to redesign one of the 2 floors and relocated employees accordingly. Some sample data here to show, for example, the peak occupancy by room, by days of the month or the week, whereby you can easily tell the different use patterns across a breakout room versus a phone booth or meeting pods, the entrance and exits details throughout the day, and the dwell times in each functional rooms per session. These high granular and high detail informations really provide an improved opportunity for the workplace management team to look into the next step. And the overarching, the total ROI of this initiative, considering the footprint reduction and reduced cost on occupancy-based cleaning, is easily $500,000 in a year, right? So pretty compelling. Last but not least, just a recent development in applying the people sensing technology to senior care. Aging is such a global challenge, right? 1 in 5 Americans will be 65 or older by 2040. Senior living communities challenged by staffing shortage. So the key here is to have technology that help reduce the workload of the staff based on the real-time insight. And our technology, which is truly non-invasive and continuously monitoring, is super exciting here to provide the capability to detect the frailty analytics based on the real-time gait speed, activity alert, how often do they get out of bed, out of furniture? Is there any no motion detection period of time that signifies some problems? How does that bathroom routine of the tenants changes, and fall detection? The ultimate goal is not just improved quality of care, improved quality of the tenants, but very importantly, caregivers can do activity-based rounding and check-ins, which greatly reduce the burden on their shoulder, right? So to wrap up, just inviting everybody here to imagine together with Butlr a more exciting future enabled by occupancy and other smart technologies in the smart building area for interior climate changing and the building to understand smartly the activity levels and behavioral patterns to safeguard the tenants' physical and mental health. Thank you.
Thank you. Wow. That was awesome. Actually, all 4 were awesome presentations. And I think we said when we all got together before that we could make an hour and a half out of any of these topics for discussion. And, I see all this, there's sort of the fruition of so many ideas that people have had starting to come to bear with what some of the stuff that's happening. So it's just so cool to see what you guys are doing, what everyone else is doing. There's lots of questions that are in the chat, which could probably drive our entire discussion for the next 45 minutes. I'm only going to ask one from the chat right now. Some of the others were going to come up. And this is kind of the bottom line person here, sort of asking, how much of this technology and all these things that I'm seeing, can we put into existing buildings? Are they viable for that? And I think the answer, everyone would probably say enthusiastically yes, but I'm just curious what you all think about that.
Yeah, from my perspective, every one of these can be applied to existing buildings. The bigger question really isn't the age of the building, it's what technologies are in the existing infrastructure that can be used and leveraged. And so some newer buildings have not very much installed, not very many points of reference of the different technologies. And so how many points of reference can you get with the existing? And if not many, or it's not enough to give you the full picture, what does it take to be able to install the new infrastructure? Does it require a lot of wire pull, or is there wireless? And then once you have that, then it's a matter of the aggregation. So how do you connect them, and how do you get it to the technologies like Butlr and Nantum?
It's kind of the classic thing with legacy systems in old buildings always, right, Craig? Only we're kind of going in a different direction than the past. Is how do you get the latest and greatest when you've already got this, you've got your pneumatic controls or whatever it is, taking it to the limit. So how do you, are you having to completely start over, or can you find a way to get there in steps to sort of get these things going? So,
Jay,
all right. So
I know,
sorry, go ahead. Yeah.
I know you have had to pivot a little bit, or not have to, but you've added an existing building component to your solution as well. Is that correct?
Yeah, so the product I shared during my presentation is really our kind of cloud product that is typically used in open to structure environments, like in the image I shared, where you can see and that, show off the CLT structure, for example. We've also developed a product we're calling a grid. This is just my term for it. This isn't the marketing term for it. It's just a grid integrated system. It's basically all of the technology in that cloud you saw and a panel that can fit into a suspended ceiling grid. So a standard 2x4 size, and we also make one that's a 2x6. And again, it's so that those panels, they can be lifted in and placed into a grid, and they come right pre-baked with lighting, the driver I showed you pre-wired with any of the technology that's hosted on it. So yeah, I believe that system is, these are 30 to 40 pound objects. They're much easier and to install, and they could go into existing grids. So I think we have not yet done one in a tenant improvement, right, or say a tenant improvement or a refresh yet, but it's definitely, we're kind of viewing that as a big market in the future.
Mm-hmm.
Yeah, I would just add
All
to
right.
that. Nantum OS, we're fully existing buildings software, but if a designer knows that a client might want these occupancy data down the line, the best thing to do during that design and bid is to, like Craig said, to make sure that the Ethernet is available or the infrastructure is built out during that design phase, because it does become a little bit more expensive if you need to go in and pull wire later on.
Mm-hmm. Mm-hmm. And just one other question, that kind of nuts and bolts kind of question that is one of the questions that got asked was, how do you prevent duplicate counting of people going in, knowing people going in and out of buildings and those kinds of things? Anyone want to just briefly answer that, or how they're approaching that?
I can take that. I mean, I think this is, it depends on the mode of the sensing, right? If you're using, so let me try to interpret the question, right? So if you're using the traffic signal, the in and out, to deduce the number of occupants in that area, that's one use case that often is applied for the building level, which we have seen customers using our sensors for. And in that case, let's say you have like 300 people in that building, and sometimes when you miscount one or two, that is considered by the customer very acceptable. What we think would be a better use case, if you are really keen about accuracy of the number of occupants in that selected area, is to actually deploy the occupancy or presence mode of the sensor, right? So I hope I capture that or interpret the question well, Sarah. Just want to make sure that we're talking on the same page here. But I think in terms of using the traffic sensor to control traffic, to count traffic, and using the presence type of sensor to count the occupancy, the error of double count or miscount is pretty minimum.
Yeah, and I think you got it to that point, the presence sensor. If you have multiple, like an aux sensor and reading Bluetooth devices, for example, then you got to set up some rules on what you're reading, and you want to triangulate those. So you might take the highest number between the two, right? Just so you're counting, maybe it's missing one. So if you've got an area that you are reading multiple sensors from, then you would want to be able to read both of those and understand you're looking at an average or a higher value of the two.
Mhm.
Yeah, in real case, actually, people
Okay,
care
so-
more about missing counting, right? Do you use high enough frame per second? Do you miscount? That's I would say in actuality, and not generic to Butlr, is some of the questions that people ask most frequently, as opposed to, do you have duplicate counting? So just want to point that out.
All right, so we're going to we have some questions here we talked about ahead of time. I want to go through some of these and really start directing this first question to Cindy, though others can lean in. And we talked about, metrics for operational energy use in buildings. And, we've used EUI for forever, where we're talking about energy intensity per square foot on an annualized basis, typically in G. Can we do better? Can we do worse? That people aren't usually looking at EUI on a daily basis or something like that. But really in theme with what we're talking about here, we're talking about occupants and there's variations in occupancy that can be dramatically different than they used to be in the past, which everybody's able to track better. Should we be looking at different metrics for how we manage the performance of a building? I mean, if you think about if a building is only half occupied, should they use half the energy? Or if it doesn't, is that wasteful? So those kinds of questions come up. So maybe Cindy, if you want to start that off, and I think anyone can lean in from there.
Yeah, sure. I have two thoughts on that. So when it comes to our clients and their energy management journeys, typically Energy Star Portfolio Manager is kind of the introductory energy management platform, right? And that's very much a static snapshot in time, deriving EUI from square footage, from your bills, and really from very little information about occupancy, right? I think
it's not proactive in terms of doing things either, because you're all looking at old data.
Yeah. Yep. And, you might be able to look back in time and see changes, but often with real estate, operations change hands, buildings get sold. So, it's not a great picture. So the starting point is having no information about occupancy, right? And I think over the past few years, we've really seen a drive and a push to understand better the occupancy trends that are present in a building. And starting from zero is, just looking for any more data, any more ways to contextualize what's actually going on within a building. With a system like Nantum, right, we're connected to a lot of different data sources, and we are able to organize different ways to understand that data, right, which is really the important part of having a middleware platform like ours. So we have had clients that are interested in having us set up different reports or different trend graphs that look at electric demand per occupancy, right? And that can change and can be visualized and be searchable over time. We had a client that had multiple floors of a building that, similar to the example I showed, where we were able to set up occupancy per floor. We were able to set up some unique graphs that were looking at comparing energy consumption over a number of occupants. And at the time, that client was actually trying to downsize their space. So we were able to kind of help them demonstrate, using energy more efficiently per the square footage of the floors that they had. Again, this is all about data and again, how to create actionable insights from that data, whether that's for operational use cases, whether that's for leasing, for tenant experiences. And then my second thought related to the occupancy, getting the occupancy data, is there's a lot of different ways that we can grab it. It's not always installing sensors. Again, any installation of additional hardware is going to have additional costs related to labor, related to material. So really it's what do you want to use that data for, right? If you're starting with nothing, maybe just having clickers in the lobby and having your security person start doing that. Maybe that's enough for you to get started in. Maybe you do want to start installing some sensors in common area spaces, or try to do the whole building. If your HVAC is not set up to allow for zone level controls, it doesn't really make sense to get zone level occupancy, right? So again, there's always trade-offs to trying to get this type of data. There's cheaper ways to do it. There's more expensive ways to do it. But really doing anything is better than the baseline that we're starting from, which is really, not having any understanding of occupancy in real time.
When you say start with nothing, there is the way you're going to measure success, though, is relative to some kind of a baseline, ultimately, right? And so, and showing that you've improved, like you showed on your one chart and things like that. So you need to have some starting point. So maybe initially is what you're saying is you do have those portfolio manager bills, and you can look at those. We're talking about energy, say, or year over year, and then you can start to get better as you get a better understanding of what's going on in the space. Then you start using other metrics for measuring your success or your improvement, and say, hey, we used the same amount of energy last year as we use this year, but this year we had returned to work, where last year no one was here. So you've got different things you're going to be able to see. Is that a fair statement?
For sure. Yep.
Okay. Anybody else want to say anything on about that particular way of looking at? I guess I'll say, let's make that a different, we talked about energy performance, but just building performance in general. Is there better ways to think about building performance? We said energy per square foot, energy per occupant. Anything else that comes to mind for anyone?
Happy to
I have another topic. Yeah.
Happy to chime in here, Tom. We are on the data collection end of the game, so I don't have as much of the in-depth reading as what Cindy and the team has. But what I can say, though, is that we've been talking with the workplace intelligence thought leaders, and they've said something that is quite relevant. They said the definition of occupancy changes in different contexts. So you have to kind of like, for different purposes, redefine it. And for example, do you count visitors who may be here for a short period of time, 20 minutes, as part of normal occupancy? And if you peel the onion, if you're talking about workplace strategy, number of people, dwell time in and out are probably all very important. And from energy consumption, from a holistic building perspective, people are talking about actual occupancy hours rather than the number of assigned occupants. And I think there's the concept of the full-time equivalent occupancy that people have been using to gauge, sort of like normalize that energy consumption over the actual occupancy, which is the total annual occupied person hours divided by the annual hours of the FTE, right? So I think that change, that the concept has been evolving. But the interesting thing here is that when you look at the data, you might find that the peak occupancy in the building increases. If you look at the EOI per square foot, it increases, right? But if you look at the occupancy adjusted EOI per FTEO, then it kind of it sometimes decreases. So it provides another lens, another set of lens to look into decision making for remote working, shift planning.
Yeah, that's a great way of thinking about it. So yeah, thinking about it as occupancy on an FTE basis versus sort of what's going on at a given point in time. So, all right. So the topic that came in as a question anticipated the next thing we wanted to talk about, which is going to stay with you, Zixiao, a little bit, at least to start it off. I mean, when I started to think about scenarios for smart buildings, whatever it was 10 years ago and things, I was all of the mind that, with these devices, you could be known and your preferences could be known, and those personalized experiences like Craig showed would be all the rage. But we always obviously have these concerns about privacy, and the sensitivity, and you've got, your clients in particular are talking about anonymity being important, some of the clients you're working with. Yet the conflict or the tension against that is optimization for individuals or optimization against preferences and stuff. So with that sort of understanding that, I'd like you to just talk a little bit about how do you take the concerns of personal privacy and security and sort of think about that from the standpoint of also providing the best experience, providing the best outcomes for individuals in those spaces while keeping the anonymity that they all want.
Yeah, really appreciate that.
Hopefully I'm asking that in a good way, but yeah, please go.
Yeah, I really appreciate that question, because we definitely see a strong increased awareness from both tenants, the companies, and the employees around privacy. A huge concern now, I mean, not just in North America, but Europe, right, that we serve, increasingly aware and increasingly sensitive about that. Interestingly, right, on the legal front, if you look at the federal privacy laws, such as the Electronic Communication Privacy Act, they do give discretion to employers regarding how far they want to carry in terms of the monitoring programs, as long as the monitoring is quote unquote within reason, right? So it's kind of vague, but over the years, at the state level, people know that, I think Connecticut, New York, Texas, and Delaware, these are the 4 states that require the employers to provide notice and kind of like a written consent from employees before that happens. And California,
only four states.
Only 4 with the state level law requiring the notice and written consent. That said, I think California, I think Florida, South Carolina, there are a couple of other states that had specifically said that the residents or the tenants have the right to privacy. So companies in those states are treating this privacy issue very carefully. For example, we have large corporate customers who had made their own policies. They're based in California, right? They basically said, we are not going to deploy occupancy sensing, even if it's anonymous, in an environment that's used by 4 or less than 4 people. Because in that small group kind of a setting, there is a chance that the identity of that group or individual from that group may be inferred, not from the occupancy data, but from a combination of data in addition to that. So companies in these states are getting more and more sensitive about that and making their own policies. So solution providers, we have to make sure the technology need to have the true anonymity, right, in that, because people know that if you say, I'm using camera, but I'm just anonymizing the data on my platform so the user don't see, you can no longer trick the users like that anymore, right? Because there's still a risk of leakage and like a breaking of the PIIs there. For tenants and landlord, we really recommend transparency and good communication ahead of time. We've had situations, for example, the landlord told us and said, Butlr, come in, install the sensors, and we know your technology, no problem, come in. But can you please tell the tenants on the day that you're just doing some simple electrician work, without explaining to the tenants what we are, who we are, and what our technology is or is not. And the tenants actually panicked in that situation. So later we kind of calm it down because we explain to them who we are and we're different. But that's just not a good experience for any party in between. So the general guidance is solution has to be providing pure anonymity, and then the tenants and landlord need to do their job to educate and communicate.
Interesting. So yeah, go ahead.
Context to the two, just from an integration perspective, you really have, how are you going to use that data? And so I think certain aspects are anonymous no matter what, right? Like an aux sensor. But when you get into things like video, can that be anonymous, right? And there's going to be a certain natural trade-off for being anonymous versus what the value proposition you're bringing. And is there a convenience factor that gives you the ability to have your Starbucks ordered the moment you drive in a parking garage, which is a very real thing that can be done today? Or is it, we had a real use case where we had a school district who used facial recognition to allow the police department and the school district administration to upload students that are expelled or suspended or any kind of threats in the city, and then it would anonymize that data. But if it was recognized that person was in the parking lot, it did an automatic lockdown of all exterior points of entry. A great use case of safety in a time when that's important. The teachers union did not like that because they then saw that as the ability to track who's coming and going and at what time. And so that was ultimately removed and we did not proceed. But again, are they willing to take a trade-off of a use case, in this case, a safety use case, for the use of that technology? Now, the interesting thing is that the video is already being recorded. They just weren't using software to analyze it. And in this case, and in most cases in buildings, the data is already there. Now what we're doing is getting better at being intelligent with it and actually being able to do something and process it with it. The second part, though, is the actual cybersecurity component that is more important than ever. And so there are, when you pair your phone to things, there are ways that if it's not secured from a cybersecurity perspective, and it is compromised, that they can track that ID of the phone or even the wireless, the Wi-Fi, through the Wi-Fi, different things. And if they then know that ID of that device, they can then track, oh, they're now in this building in New York. Now they're in this building, and they only go to that building in San Francisco when something's going to happen. And so then they're tracking bad actors where that device goes. And so that was a real use case that was demonstrated at a conference I was just at. And it's unbelievable what they can do anymore. And so that just reinforces the importance of cybersecurity with all of this, where we've had recently a couple school districts locally who've been hacked and taken down the network. And, it's a real threat, and we have to protect from a cybersecurity perspective.
Yeah, there's definitely a lot of upfront education to do with clients around how a system like Nansen uses occupancy data. So there's multiple different ways that we can actually get that data from building systems. But once that data makes it up to Nansen, really all we are looking for is a real-time count, right? So we're quite sensitive about using the right terminology. So if we're going to install sensors, we're going to call them sensors or counters. We're not going to call them cameras, because clients actually are quite sensitive about language, our Canadian clients especially. There are times when we can actually work with existing building systems to scrape occupancy data. For example, Wi-Fi systems sometimes have modules that you can turn on that can basically take the number of devices that are pinging up to the Wi-Fi system, and then through some algorithmic calculations of their own, convert that number of devices to number of people. And we've actually done some comparisons around scraping Wi-Fi data versus occupancy sensor data. They can be quite close. We often tell our clients that are skeptical about that method that, hey, if you're ever shopping in a big retail box store, they have that on. They're using that. They're pinging to your phone, and then they're delivering ads and coupons, et cetera, based on like where you are in Target or Home Depot.
Yeah,
right?
in some way, the genie's out of the bottle already on this stuff. Yeah.
Yep. So we're utilizing that same type of technology that unfortunately we as Americans are quite embedded in already. We're just using it in a different use case, and for us it's to save energy. So again, it's just context, it's storytelling, and it's making sure to get ahead of that problem.
Yeah, just a quick one this is not on the script here, just thinking Cindy, Jay, probably Craig as well, that real-time heat map stuff that Zixiao was showing us was super cool. Could you forecast a way to actually respond with what you guys are doing that would actually be able to take advantage of that level of dynamicism or dynamic changes as they're going on? Or is that just too much information that you can sort of, what do you really do with that? You have to think at a higher level of granularity to make use of it. Does that make sense as a question? Hope it did.
Yeah, I think it makes sense. I think, it's really a visualization, what she showed of, like in our case, we were putting a multi-sensor that has a motion detector that's looking down, right? In our way, it's really just graphically displaying that at a much finer grain, right, level. So
correct. Correct. You can see how you can create the heat map that way. So that part I understood. His question is, can you use that kind of information as something over time to figure out better ways to operate the building, or would there be things that you would do differently just from learning that learning what that looks like, I guess.
I mean, I guess I could see, I mean, in the case, we had 15 different little cubes, if you will, or
Mhm.
looking at a volume in the room, you could theoretically take, that information and then overlay the same grid on that. And, instead of necessarily having to have, one sensor per area, you have fewer sensors, and you can utilize the data in the very same way. I mean, so I think it's really just, to me, it's about inputs and outputs, and like, if there is an occupant in that zone in the cube, in the room here, do something with that information.
Mhm.
And so that's really, in our case, it's about, so simple inputs and actionable, like when you have the input, what do you do with the information? So.
Mhm.
I think it's easy.
So to what I hear there, and I think actually, Craig, this is a question that was also tagged a little bit towards you as well in terms of granularity data and making it actionable. So there's the responding as you see things happening in spaces, and is there something that can be learned? So the other part, so I want to hear about that, but I also I am curious, what can we learn if we look at the data over a year's time in terms of these things, or a month's time? And does that give us insights, and what are those insights that might help us as well? But go ahead, Craig. I think this was one of your questions too.
Yeah, ultimately, it comes back to what use cases are you trying to solve, and they can vary dramatically based on your building type. For example, the airport of Atlanta had a problem with delays and layovers because the people who, the wheelchairs and the wheelchair people that push them weren't in sync. And so they put a Bluetooth sensor on every wheelchair, and they put a Bluetooth, the iPad, and with every person that was carrying it. And so then they were able to now use that data to create a whole different sense of where devices are at, and where wheelchairs, where people are at, to get them to the right location when they need to, on time, to be able to reduce delays and layovers. And so that's a simple use case. I mean, we got high rises downtown who are wanting to solve the challenge of when it rapidly shrinks on the floor of occupancy. How do I drop my ventilation load and air changes per hour to save energy? But I can't put sensors throughout my whole building and throughout the whole entire space. And so just everyone has their own use case. And some of those use cases are short term, some are longer term from planning and strategy. And only you can bring those use cases. What you just have to do is find partners that can help walk through those use cases and say, okay, well, now, how do we solve that? What can be solved with the existing infrastructure or not? And ultimately, air quality is still a predominant component of what we live with today. And how do we use this data to also drive and supplement the air quality challenges that we have?
Mm-hmm. So granularity, use case is going to depend on use cases, what you're trying to solve. There's obviously a financial aspect, which we're going to talk about here in a few minutes. Do we think we have a situation now where we're at with computing power and capabilities? Is there a data overload possibility still with having too much information in the building?
You don't orient around a use case, yes. If it's trying to get more data, then absolutely. But if you have a plan for how you're using that to drive a sequence of operations or make better decisions, then it's not.
Yeah. Okay. All right. So this one, I got Jay in mind for this question. It seems that with the variation in occupancy patterns, the implications are, lighting, HVAC, indoor air quality. There's implications of all of those. However, these systems often have independently controlled systems. And so what is the degree of difficulty in getting these things reacting to a single stream of occupancy data? It seems like that's kind of what you're part and parcel of what you're doing, isn't it, Jay?
Yeah, I mean, that's, in the demo that I kind of showed, it was really all about the controller, putting one of those on each cloud, and that controller has a series of inputs. low voltage inputs, and you plug, right, the occupancy sensor into this input, then that, right, you program the software to then, right, read that input and do something about it. So it's really in my view, and in my experience, very limited experience in playing with this in this realm, it was about the controller. That controller had so many ports that you could plug into it, and then I think I think the other thing about that particular controller and that company is I think of them as an open source platform, right? That yes, it reads BACnet, but it has APIs, as Craig mentioned. I think they are trying to be agnostic about the devices that plug into it, and then having a back-end software platform that you can then tell it to do, right, anything with that information. So we're currently working to take an air quality sensor and plug it into that same controller. It's an aware sensor. It can read CO2 levels, particulate matter, you name it, and then do something about that. So let's say it's CO2, taking and turning on, maybe CO2 is a bad example. Let's say it's a particulate matter. So PM 2.5, let's say. If that number is, reaches a certain point, then that aware sensor is plugged into the DISTEC controller. There you go. And then that will turn on a MERV 13 filtration unit, right? Or turn it off. So we're kind of playing with ways to make our platform more healthy, right, for indoor air quality, as in that example. So I think it's agnostic to device. I think is key, and having a control system that is flexible enough to deal with the inputs, right, that are coming at it. So
very good. So I think Zixiao, you probably showed, I think we're the one who showed some paybacks on some of the things you're doing, but that's kind of what's in everyone's mind, right, around this stuff is, new deployments, new technology, different. Obviously, you guys are all at different places where how you're in one's, one person's applying, one person's working with the data, another person's analyzing data. Here we got on this call today. But when you start to think about it, what is the ROI on some of this stuff? What's the size of the prize? What are we going to be trying to capture? What are the value streams? And are we actually being able to measure them? Cindy, you probably have the best case, a way of showing that and measuring it. But there's a cost for what you're providing, a service you're providing. And are you able to show the value in that? And are there other things you think you can do that would increase that value proposition, that would sort of make it compelling for somebody over time?
Yeah, so with Nantum and our energy optimization, most projects pay back within a year. So we've got a very good return on investment with our core stack of energy conservation measures. What we do have to think about is, again, the floor by floor capabilities, right? So in DC and built in cities with smaller size buildings where top floor maxes out at 12 floors maybe, and we've got the air handlers that are set up floor by floor. It can be very, very economical to really go install those floor by floor occupancy sensors to get that additional, couple more percentages of energy savings. In New York City, high rises, once we get to that level of floors that need to install, right, then your installation costs are going to go way up, and it just may not be as worth it of a trade-off when monitoring occupancy at the whole building level might get you enough of that savings measures, right? Then again, there are some times when we can get security turnstile data where tenants are actually badging in and badging out, and the system is set up to tell them exactly where they go, and we can scrape that data. Again, many different ways to get occupancy data. It all kind of depends on what you're going to use it for, as well as what's already there in the building. How much is the cost to integrate? How much is the cost to pull that data out? And really is squeezing out 1% more of energy savings potentially good enough to justify the additional cost for setting up the system.
Anyone else want to? Go ahead, Craig.
So we're seeing a couple different things. ROI and being able to do just based on energy savings is really tough. If you're going to put the right amount of sensors in to really give you a good strategy on a retrofit. But what we're seeing is the other value props are now giving us points of reference that can be then used. So like security, security is becoming a bigger challenge nationally. And so more access control, more video to be able to help boost that security component. But then with that, you get the occupancy component data from there. When you start looking at other value props around commercial real estate that has an occupancy challenge, and we have tenants downsizing, spaces open up. Now a landlord has to really sell that property to get in a more competitive market. You start looking at occupant experience. And so we're starting to see occupant experience and apps that allow someone to be able to see, the amenities and be able to reserve a room and all of those other things, but also have the integrated access control, have it integrated for wayfinding, have it integrated for other personalized lighting and HVAC. And so when you now start go ahead.
Sorry. So what you're saying is that providing those kinds of things, you're providing a competitive edge in a much more difficult market situation.
Yep.
For leasing up is what you're talking about for a lease up situation.
And it just cycles back. You've used that value prop to be able to afford it. And it now gives you something to be able to use from an energy perspective and an operations perspective.
Go ahead.
Quick here, I think it's really well summarized by Cindy and Craig here. And I just want to add, from our observation, it's interesting because the use case, you can actually see the use case and the buyer persona evolves even within one customer. Because, remember during pandemic or right after pandemic, typically the first group of people in the CRE space, especially the office space, that requested occupancy sensing are coming from, let's say, a company's finance team, the CFO, basically by saying, hey, we need to consolidate because people are not here. So that's the first batch. And then you see the workplace experience team coming up and say, okay, now I have, I've done the consolidation. I have 40% of people, are going to come back to this consolidated building. How does that work? Do I have enough amenity, right? And then evolves into how do I redesign the workplace so that people are encouraged and incentivized and happy and be productive. Then the facility management and maybe the landlord on the landlord side, as Craig just said, right? How do I make decision and early ahead of time to prevent some of my tenants from, escaping and lose the lease value. So when we talk to the CRE space customers, you can see that there's the one-time immediate payback for them to make decisions on footprint consolidation. And then there's this long tail ROI from different angles and different teams needing that information to make decisions, whether or not it's experience or productivity or energy. So
in other words, to meet their goals, they find this data is very helpful, and so they're not necessarily direct monetary measurements, but it's allowing them to achieve the things they're trying to accomplish
exactly
in a more efficient ways. So yeah, that's sometimes the challenge with this stuff is it's not as easy as energy savings where there's a direct utility bill thing. And in fact, in buildings where you have tenants and landlords, sometimes it still doesn't work as an incentive depending on who's paying the bill for that. So you do run into these challenges certainly. There are a couple of questions in the chat, Cindy, that I think are directed to you. I don't know if you want to look at those and say anything about those two at the end here. We're running just about down to our last. Actually, I think we're just about down here. I'll give you a minute and then we'll say our goodbyes if you'd like to say something to that.
Yeah, sure thing. And thank you everyone for the questions. I'll quickly answer about the local law 97. In New York City, the building energy performance standard mandate is a huge driver for software systems like ours, as well as, you know, other energy management systems that are out there. For most of our clients who are typically, you know, in the Class A building space, the upcoming 2024 compliance year is they're good for that year. So it's really looking towards 2030 is the big year that, you know, a lot of our clients are going to be facing fines. So between now and 2030, it's really a decision about how to use their CapEx, right? Are they going to make operational improvements because they're just a little bit over their cap, or are they going to have to invest in, you know, much larger equipment upgrades and CapEx expenses? Next question on other factors about installing Nantum. Again, you know, we try to really leverage existing systems, and for us, usually the piece that we have to work with and the piece that can get expensive is working with the control system, right? So really, how modern and up to date is your BMS? How you know, willing to work with us is your controls vendor? We have had good experience working with, you know, the major players that are on BACnet or on Modbus or Niagara. Those are, you know, easy systems to work with. But again, the older, more outdated, any legacy devices that aren't on BACnet or one of those, that's when, you know, it can get harder to make that BMS ready to integrate to platforms like ours that are, you know, pulling data out of it.
Yeah. All right. Well, thank you. Thank you first for the audience out there who we can't see, but thank you, panelists. This has been a good discussion. As I said, I think we could have had long discussions about a lot of the topics here and not really given them full justice. So hopefully we've gotten a little bit going for the people. There are a few questions in the chat that didn't get answered. I may stay on just for a couple of minutes. If anyone wants to stay on of the panel and just write in answers, they can do that. Otherwise, this is the end of day one of SBX, and sessions begin tomorrow. That is August 16th at 9 a.m. Pacific time, which is where I live. So, and again, thank you, everybody.
Thank you. Bye.
Thank you, Tom. Thank you, everybody.
Thanks, everyone. Take care.